right? Uh, we just going to solve how many? One, two. Okay. We are going to solve just one problem for now because I think we might run out of the time, and there is something more important that we need to talk about as well. So what I'm going to do, I'm gonna give you like 3 minutes. All right. What you can do right now, you can just kind of write down this question on the piece of paper or the notebook you have, right? And try to find out what is the answer. But before we do that, I am gonna go back to the, in case if you do not have the handout that I share with you, I'm gonna go back to the table in which there is a unit conversion value has been given to you for milliliter and nanoliter. So you can use that. All right. So please write down this question. All right. And let's see if you can solve this. I'm gonna give you like 3 minutes to solve this. All right, it's 450 ml equals to how many small n liter? It means nanoliter, right? In case if you do not have the value, right? If you do not have the handout with you, you can use this slide, right? The information which you need is already given. I'm gonna let you find if you don't know, and then we're gonna work on this in a after 3 minutes. All right, so you have 3 minutes to find out the answer. The question was 450 ml is equal to how many nanoliter?
I got that. Uh, Dr. Pratik,
Yes,
it's 4.50 milliliter to nanoliter, right?
4.50 ml to an yes, nanoliter.
Oh, okay, I got that.
Okay, I'm still going to need to wait for like everybody to kind of try and see if they can get the answer. So I'm gonna still wait for like 2 more minutes and then we're gonna discuss. Okay.
All right.
Yeah. All right, guys. So I hope you guys have already tried, and if you guys got the answer, it's wonderful. If you haven't, and as long as you have tried, that all it matters. All right, so let me just talk about that. All right, again, what we are doing here, we are going to convert ml into nanoliter. If you look at the table that it was on the screen, you can find out that there is no direct relation, at least in the table that you know, that is between ml, how you can convert ml into nanoliter. There is no direct relation. So what you can do, you can just simply convert that into like two simple steps, right? The first step saying that okay, just give me one. Yeah, 1 ml is equal to how many liter, because we are talking about the unit liter, right? So 1 ml, milli means 10 to power of minus 3. And I hope you guys remember that. All right, if you haven't, try to remember as much as you can, so please do that. All right, so it's going to be 10 to the power of minus 3 liter. And other conversion that we have with the nanoliter, what we know, 1 nanoliter is equal to 10 to the power of minus 9 liter. So again, we can use two steps conversion to get to our answer. Is that clear? Do you understand this?
Yes. Yes.
Yes.
All
Yes,
right.
Professor.
Okay, so then it's very simple. We just need to understand what conversion factor we're going to use first. So of course, first step is to write down whatever is given to us. So 450 ml. Of course, ml is given to us, so we're going to use the conversion in which there is a ml that must be in the denominator and the liter on the top. So ml is the first one, right? It is the only conversion factor we have in which we have unit ml. All right, the other unit we have on that conversion factor is liter. So what number we have in front of ml? 1. What number do we have in front of liter? 10 to power of minus 3. Doing this math, we cancel out the unit ml, right? And let's just do the math. For now, I'm just going to put the number like this in a scientific notation, right? You can definitely do the math at your, like, using a calculator. So this is the answer we're going to get. 4.50 times 10 to the power of minus 3 liter. Now, is that what we want? No, we don't want answer in liter. We want our answer in nanoliter. So what we, sorry? Okay, so what we're going to do, we are going to use second conversion factor that we know, in which we're going to put liter in the denominator. Why? Because we want to cancel out this unit. Also, another reason is we want our final answer in nanoliter, so we have to put that on the top. If we do that, let's look at the numbers in front of nanoliter. The number we have in front of nanoliter is 1. The number we have in front of liter is 10 to the power of minus 9. All right, so when you do the math using this number, so 5 and 10 to the power of minus 3 multiplied by 1, 10 to minus 9. If you do the math, you will get your answer, which is going to be 5.0 times 10 to the power of 3. Sorry, 6. 6. Yeah. All right. Did you get this answer? 4.50 times 10 to the power of 6.
Yeah,
Yes.
I did.
But how did that happen with the
Sorry. Okay, let me just explain you how to do the math on this, right? If you know how to plug in this number in a calculator, you probably can get the answer. If you do not want to use the calculator, let's say if you're kind of good enough in the math, this is the way you can solve this problem. So 4.50 multiplied by 10 to the power of minus 3, right? And you can say 10 to the power of minus 9, right? This is the what you have, right? Or you can just put it down right underneath this, right? Same thing. Now, what we can do, when you have 10 to the power on something on the top and 10 to the power on the denominator as well, what you can do, it is a mathematical equation that you can solve. You can just keep the number as it is, 4.50 multiplied by 10 to the power of minus 3, because you already have that. And when you have 10 to the power of something in the denominator, if you want to bring it on the top, it becomes 10 to the positive sign. this is something like a math, right? It's a rule of the math that if you have 10 to the power of minus 9 or 10, if you bring it on the top, it become positive number. So what you can do, you can simply put the power 10 to the power together, right? Minus 3, which you already had, the minus 9 was in the denominator. When you bring it on the top, it become positive 9. If you solve the math, minus 3 plus 9 is going to be 6 plus 6. So that is going to be your answer. 4.50 times 10 to the positive 6. Right? This is the math you should kind of understand. If you do not know yet, then now you know. Do you understand this?
I don't know how you got the final product.
You mean this?
Yes, I like that last step. That last step.
In here?
No, at the bottom. Yes.
Bottom?
Yeah. Yes.
It's the same step what I did here, right? Did you try to plug in this number in your calculator?
Yeah, I didn't. And it says error.
Okay, then probably you may not have entered it correctly. So what we can do for that, you like once everything is done, right? After 4, like once everybody's done, you can stop by for like, you can stay like a couple of more minutes and you can show me your calculator. I can help you to explain you how to use the calculator correctly.
Okay, thank you. And one more question.
Yeah, go ahead.
Find the known conversions. Like, how did you like determine that?
How do you determine what?
The known conversions, 1 ml equals 10 to the negative third liter. How did you get that? Because I don't see it on the.
If this is the prefixes that we are talking about, you see these prefixes?
Yeah.
Milli, right? This is just a prefix. As I told you, you can put any unit after this, right? So m, if you put capital liter, now it's liter. You are talking about ml. So this is the conversion you get. 1 ml is equal to 10 to the power of minus 3 liter. The same way, nanoliter is equal to 10 to the power of minus 9 liter. Do you understand this? We can apply this prefix, the prefix we are talking about, deci, centi, milli, micro, nano, pico, femto. We can apply that to any unit. We can apply that to the gram. So let's say, for example, if I'm gonna call this decimeter, it equal to 10 to the power of minus 1 meter, because I'm talking about the unit meter. In here, if I'm talking about the unit gram, centigram, right, we can talk about 10 to the minus 2 gram.
I get it. Thank you.
All right, so you can apply this prefix to any unit you want, and that's what we did here.
I have a question.
Yes, go ahead.
So this problem, like I converted it to decimal notation. Would it still be considered right? I'm guessing the scientists like it's a shorthand version. That final answer, 4.50 times 10 to the 6. If I have like 4, that long thing, it would still be considered right.
It actually not really, and
No?
we are going to talk about why.
Okay.
Right? Because like, when we talk about solving this kind of problem, we have to keep in mind that how many significant figure we are gonna use, and we haven't talked about that yet. But in general, your answer is right. But when you have to put your answer in correct number of significant figure, in that case, it is going to be wrong. So you get the point, like let's say if it's 2-point question, you may lose like 0.5. It's just because you didn't do the last step correctly. That's it.
Okay, that makes sense. Thank you.
Okay? Yeah, no problem. Any other question before we move on, guys?
No, sir.
No.
No.
No, Professor.
All right, great. All right.
Professor,
Yes, go ahead.
before you go, could you show me how to plug in those digits into the calculator?
Can we do it after 4? Because like
After?
everyone
Sure,
has different calculator. Like if you're using your iPhone, if you're using a Samsung phone, if you're using actual calculator, everyone has like different ways to plug in the numbers. So
Okay, thank you.
wait? Yeah, great, no problem.
Sure, afterwards.
Okay, great. So again, at this moment, because of the time limitation, I'm not going to solve this problem right now, but I think you can just take the picture of this. You have all the formulas that you need to solve this problem, and you can do it later on. All right. So in this question, what I gave you is, I gave you the quantity in the kilograms, and I'm asking you to convert that in mcg, micrograms. All right. So use the table that I have already given you, right? Use the table to come up with the conversion factors. Once you know the conversion factors, plug in the conversion factors, plug in the values, and see if you can get the answer. All right. So this is like kind of homework question for you guys right now. All right. You don't have to show me your work, but you should attempt this. All right. So please take the picture. I'm gonna share this as soon as it's available, but for now, just take the picture and solve this once the class is over. Okay, so now we are going to talk about significant figures. So, right, one of you just asked me that if you write the number like this, right, 450000, is that right? Of course, your answer mathematically is right, but the presentation that you have, it could be incorrect. All right, so let me just explain you why. So if I'm gonna ask you this question, all right, I'm gonna let you do the math. Use your calculator. 2.851 multiplied by 6.2325 and 3. All right, I'm asking you to multiply this number and share your answer in the chat box. Okay, so I'm gonna pay attention to the chat box. Just wanna see what number you get. Simple multiplication. Oops.
Wait, Professor, I think the screen went out. What were the numbers?
My mistake. All right. Okay, right here.
Is it 17.76894,303?
Okay. So I just want to give you like 10 more seconds for everybody to put in your answer in the chat box. And I want everybody to check the chat box, right? If you look at the chat box, you can see you guys can come up with different number, right? Some of you have like 8 digit, I would say, after decimal place. Some of you have 6 digit, some of you have only 3 digits. You can see that, right? Some of you have 2 now, right? So there is kind of inconsistency between this, right? Just to avoid that inconsistency, what we have a rule that is called significant figures. All right, so if you have done it, it's great. You don't have to kind of solve this anymore. So that's why the significant figure kind of comes in a play. We should know that how many actual digit we should put down when we do the math. All right, so there is a rule for how many significant figure it has to be for the answer when we are doing multiplication, or when we are doing division, or if we are doing addition, or if you are doing subtraction. But before we talk about that, we should know what is significant figures are. So all the digits you have in the number that are considered as significant figure. For example, the number that you have, which is 2.851, if I'm going to ask you how many significant figures are there, what you can say, the significant figures are 4. It simply means that how many digits do you have in this number. So it's 1, 2, 3, and 4. Does it make sense? Simple, right?
Yes.
Right, the same way, if I'm going to ask you how many significant figures you have in the second number, what are you going to say?
6.
Yeah, 6.
Everyone agree, right? 6, that's right. So significant figure is how many digits do we have. But there are certain cases, that is basically these 2 cases in which we are not going to consider 0 as a significant figure, right? When you're going to learn this in the lecture, there are actually 5 or 6 different rules, but all those rules you don't have to remember, right? As long as you remember these 2 rules, you are always going to get the right answer. So why we need to remember all 6 rules when we can just remember 2 and get the right answer? So what is that rule are? All right, so remember, there is only 2 cases in which we are not going to consider 0 as significant figure. In every other case which does not apply these 2 rule, we are going to count even 0 as significant figures. So of course we see in this example, if there is any number other than 0, yes, we do count it as significant figure. But even if it's 0, we are going to count it as significant figure. Exception is these 2 cases. So what is the rule? Everybody must pay attention. The rule is, if the number is less than 1, right, the number has to be less than 1. If that is the case, then what is the rule? It says all the 0, if you have just 1 0 or more 0 before your first non-zero digit, before your first non-zero digit, are not considered as significant figures. For example, if I'm going to give you a number like 0.0251, what does it mean? If you look at the value of this number, is it smaller than 1? You will say yes, right? Because it's 0 point something. It means it's smaller than 1. Everybody agree? Yeah?
Yes.
Yeah.
Right?
Yes.
Great. And what the rule says, if the number is less than 1, so yes, it is less than 1, all the zeros before your first non-zero digit. So this is your first non-zero digit. So everything before that, all the 0 before that, is not going to be considered as significant figure. So if I'm going to ask you a question, how many significant figure do you see in this example? What is the answer?
3.
3.
3.
That's
3.
right. Amazing. Great. 3. All right. So remember this rule. If the number is less than 1, then all the 0 before your first non-zero digit are not significant figure. Okay. The second rule. All right. We're going to talk about a couple of example in the next slide. Right. So please remember this rule. The second rule, the number has to be greater than 1. So yes, if the number is greater than 1, and there is second condition, right? It's not just the one condition. The other condition is, and it does not have decimal point in the number, right? If I give you a number, which is of course more than 1, right? Larger than 1, and it does not have decimal place at all, then in this case, all the trailing zero means the 0 on the right side of the number, right? Or on the tail side, are not considered as significant figure. All right, I would say at least take the picture of this slide, because on the next slide we're going to take the few examples. So if you can't just remember it right now, you can at least review it when we're going to solve the problems on the next slide. All right, so first condition was, if the number is less than 1, then all the 0 before your first non-zero digit are not significant. The second condition or second rule is, if number is greater than 1 and does not have any decimal point. In that case, all the 0 that you have on the right side of the number, or the trailing 0 or tail 0, are not going to be considered as significant figure. Every other 0 you see in the digit or in number, you are going to count it as significant figure other than these 2. Okay.
So,
And yes.
what does that mean for the answer to the equation you gave us? Is it just the whole number that's the answer?
Yes, I'm gonna show you the example in the next slide, so it will be more clear to you. But I just want you to focus on the like words right now. Okay, I'm gonna show you the example in the next slide, so it will be clear to you guys.
Okay.
All right. And the third rule is what? You apply the same rule, the one number 1 and number 2, even if the number is in a scientific notation. The only thing you have to keep in mind is, you just need to ignore whatever you have with 10 to the power of 10. For example, let's say if I'm going to give you number 2.851 multiplied by 10 to the power of 3 or 9 or minus 5, whatever it is, how many significant figures are there? You're simply going to focus on the numbers, not this. You just ignore this part. You do not worry about it. How many significant figures are there? 1, 2, 3, 4, 4.
4.
All right.
4.
Yep, correct. So even if the number is presented in a significant note, like scientific notation, all you gotta do is apply the same rule that we know only to the number that we have, right? Just ignore the part which is multiplication of 10 to the power. Is that clear, everybody?
Yes.
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 Yes. Amazing,
Yes.
great. So let's
Yeah.
try it now.
Prof, please a quick question.
Yes, go ahead.
Okay, please, you said earlier that this is recorded. Are we going to have access to it after the class?
As soon as the recording is available, I'm gonna share it with you. So maybe like we're gonna have like 2 sessions today and tomorrow. So if possible, I'm gonna share, like I'm gonna email you the both link tomorrow, or maybe like
All
on
right.
Saturday. So you're gonna
All
have
right.
the link. Yeah.
Okay, thank you so much, because I'm missing some of the lectures because my network is not really straight.
Okay, I understand that.
I'm
Don't worry.
sorry. All right, thank you so much.
All right, no worries, no worries. All right. So I hope you guys kind of at least took the picture of the previous rule that like on the previous slide, and let's just apply that, right? We are going to do this fairly quickly, but I'm gonna make sure that everybody understands that as well, right? So let's take about the first example, right? If I'm gonna ask you how many significant figures are there, what your answer should be?
4.
4.
4.
Everyone agree, right? Everyone? 4. Simple. You just count
4.
2, 3, 4. That is 4 digit, right? The second example, what do you think it is? How many significant figures are there?
3.
4.
4.
2.
3, 4.
Oh, sorry.
All right. So
4.
that's why I say it. All right. So let's take it one time. All right. We're gonna go back to the previous slide. All right. I want you to take the picture of this. Right. The first 2 rule you have to keep in mind. Only in these 2 cases, you are not going to consider 0 as significant figure. In every other case, if you have 0, you are going to count it as significant figures. All right. I'm going to give you like 10 more seconds to take the picture, and then we're going to go back to the practice problem. Okay. All right. In this, answer is 4.
4. Okay.
Why? Because this
More
number
than 1?
is more than 1, right?
Yes.
And it has a decimal place, right?
Yes.
The number is greater than 1, it has a decimal place, so none of the rule apply. So every 0 is you're gonna count it, right? Let's keep it straight and simple. How many significant figures are there?
7.
7.
7.
7.
7.
Right?
7.
Number is greater than 1, it has a decimal place, all the 0 is going to be counted. How many significant figure here?
5.
5.
3.
3.
3.
3.
Oh yeah, 3.
5. 5.
Bigger than 1.
Decimal and
Have a decimal place, right?
Yeah.
See that?
Yeah.
Right. So again, just we are learning it today right now. Of course, just keep in mind, right? Repeat. You will understand that. Because we have decimal place, second rule does not apply. It means, yep,
4.
it's all the significant figures.
4.
1.
4.
4.
Oh, 4 decimal field. Got it.
4.
No,
Right.
1. 1.
4.
Or
We have a decimal place. Yeah. We have a decimal place. It means
Oh,
the
yeah.
second rule does not apply. Right. I know you need more time to process this, but because of the limitation of time that we have, I have to. All right. But you can process this like later on, right? As long as you can read the rule one more time.
2.
Example.
5.
2.
2. Is that
2.
point? Is that a
2.
5. 5.
5.
It's 2.
It's a decimal.
Five.
Right.
5, really?
You see the decimal point right here,
Mm-hmm.
Yes.
right? Yes. As long as it has a decimal place, you are going to count all the zeros.
Oh, okay.
Right? If there is no
Got
decimal place, right? Similar example right here. This is going to be easy now. What do you think it is?
2.
This.
5,
Two.
2,
Two.
Two. That's right.
Smart.
Awesome. Awesome. Right? No decimal place. That's first point. Number is greater than 1. Yes. So now the trailing 0, the 0 at the end, you do not count it as significant figures.
Okay.
All right. Make sense?
Yes.
Yes, Professor.
Let's talk about this one.
Three.
3,
3,
3.
3.
That's
Not three.
awesome.
3.
3.
Awesome.
Yeah.
All right. Again, number is greater than 1. It does not have decimal place. What it says, the trailing 0 is not going to be considered as significant figure, but you are going to count this 0 as significant figure. All right. So this is going to be counted. The 0 in between the two non-zero number, you are going to count it. The rule only says trailing 0, 0 on the right side of the number. Those are the only one which you're not going to count. Make sense?
Perfect. What if it was like 102,003? Do you not count the 3 either?
Like this.
You count every number.
All right.
We count all.
Let me just ask you
6.
guys, what do you think it is?
6.
6.
6.
I would.
Yes, 6. What you're looking at this? You're looking at the number which is greater than 1 and
1,
does
1,
not have
no
decimal
decimal.
place, right? Does not have decimal place. But what the rule says? Then all the trailing 0 is not going to be counted. You do not have any trailing zeros, right? Because you have the non-zero number on the right side. If you have like 2 more 0, then you can say yes, it is 6, and you are not going to count the last 2 0. Make sense?
Okay.
Yeah.
Right? Make sense, everybody?
Yeah.
Yes.
All right. Let's talk about this one. This is interesting.
3.
3.
3.
Yes, 3.
Awesome.
Third rule, we're going to ignore this.
Right? Just ignore this part.
3.
Right? You guys going to ignore this part. You're going to look at this number. The number is greater than 1. Yes, it is. It does not have decimal place. It have. That's it. You do not apply that rule. Right? All of the number is going to be counted. 1, 2, and 3. Are you guys following me?
Yes.
Yes.
Yeah. Yes.
But I. Okay.
3.
Talk about the first
3.
one.
3.
4.
3.
3.
The number is less than 1. Then all the 0 before your first non-zero number are not going to be counted as significant figure. You see that?
Yes.
Yeah.
Make sense?
Yes.
Yes.
Yes, sir.
All right.
4.
4.
2.
2.
2.
4.
2. 2.
2.
3.
4.
3.
1.
3.
That's
2.
interesting.
I feel like it's 3.
Let's look at the
I
rule.
feel like it's 3 though.
All right, let's look at
1.
the
I
rule.
feel like it's 3.
I feel it's 3 or 1. 3.
2.
2.
Let's look at the rule,
I
right?
feel like it's 3 or 2.
The number is less than 1. It is. Then all the 0 before your first non-zero. So all of these are not significant figure. We did not talk about anything here. So yes, it is going to be counted. You see that?
Yes.
That was
Yeah.
the reason why I was keep repeating my words, right? Remember the words, remember the rule, what it says. As long as you put it down in a word to word, it will be right. All right. It only talks about the 0 before your first non-zero number are not significant. It didn't talk about the last 0, so it is going to be counted. All right. And the last example,
6.
6.
6 or 7.
6.
I want you to guess one number. It should be
6.
6.
6.
awesome. Awesome. Right. Again, the rule number is less than 1. Then all the 0 before your first non-zero are not going to be counted as significant figure. Everything else will be counted.
Okay.
All right.
Okay.
Do you get
Okay.
that part?
Yes, Professor.
Yeah.
It's fun as long as you can remember the rules, right? It's not hard. You just need to kind of repeat this rule in your head, maybe like 3-4 times, and you will get it. Okay. All right. Sounds good.
Yes.
Yeah.
Right.
Yes.
Okay. Awesome. Awesome. All right. Because of the time limitation, I think
Wait, can you go back, please? Sorry, sir. So I could take a picture.
I'm gonna share with
Okay.
you anyway. Right? May not today, but I'm gonna share this with you over the weekend anyway. So if you take the picture, it's nice.
All right then.
So, okay. Because of the time limitation, I can't just go over all of this, right? But I just can talk about this quickly. All right. So the temperature, these are the formula you need to remember, right? Again, you don't have to remember all of this because it's going to be online exam. But yes, I would prefer you to remember these formulas. It is very, very important to be able to kind of convert the temperature in degree Celsius, degree Fahrenheit, or Kelvin. The formula to convert the Kelvin into Celsius or Celsius into Kelvin is the first one, right? If you want to convert the temperature from Celsius to Kelvin or Kelvin to Celsius, you can use the formula A. It's a very simple number, 273.15, right? Again, you don't have to remember this number. You can at least keep this formula handy. It's good to kind of remember whatever you can, all right? The second formula and the third formula is kind of rearrange. It's the same formula, which is kind of rearrange in a different way, all right? So you can remember either way, or you can just have both of this handy.
Right,
This
Professor.
both formula talks about how you can convert degree Celsius into degree Fahrenheit or degree Fahrenheit into degree Celsius. All right. I think in 201, you may say this formula in the book, right? It doesn't matter. Both formula is same. If you want to write down 1.8 or if you want to write down 9/5, it's the same thing, right? So it doesn't make any difference. In the first formula, the formula that you see on the left side, we use 1.8, as you can see. In the second formula, which is on the right side, we use 9/5. But if you simply do the math, if you divide 9 by 5, you will get 1.8, right? So it's the same formula. You can use any formula you like, right? I generally prefer to, like, I do remember this formula, which is on the left side, right? I do use this formula, but you can prefer, like, you can remember, or you can use any formula you like. All right. So in here, if you have to solve the problem, you simply plug in the value in here for degree Celsius, right? Let's see if I'm going to give you 30 degrees Celsius is equal to how many Kelvin. All you're going to do, you're simply going to replace degree Celsius with 30, the number that you have, and just add them up and you get the answer. All right. The same way, if I'm going to say if it's 30 degrees Celsius, find out what is the temperature in degree Fahrenheit. All you're going to do, let's say if you're going to use the formula this, right? So degree Fahrenheit is equal to 1.8. You're going to replace degree Celsius with the number that you have. So in this case, it's 30 plus 32, right? So you're using the same formula in which you are replacing degree Celsius with the number you have, and simply do the math, which I believe everybody know how to do it. All right. In other way, if I'm gonna give you 30 Fahrenheit and I'm gonna ask you what is the temperature in degree Celsius, right? You can use the third formula if you want, or you can use the second formula, right? I think using third formula would be easy. So let's just use third one, in which you're just going to plug in the number. Instead of degree Fahrenheit, you're gonna plug in the number that you have, 30 minus 32 divide by 1.8, right? Simple math, do the math, and you get your answer. Are you guys following me? Do you understand this?
Yes, Professor.
Yeah.
Again, you don't have to remember this formula, right? I would like you to remember at least 2 of this formula, but again, it's just me. I like to remember stuff. But if you don't want to remember this formula, and anyway, I think in a lecture exam, your professor is supposed to give you this formula anyway, so you don't have to remember this. But if you can remember, it's great, amazing. And again, because of the time limitation, I cannot go over the concept, which is like a density and specific heat, but we are going to talk about this maybe tomorrow. All right. So
All right, Professor.
I
Thank
have
you.
appreciate. I'm gonna solve. We're gonna solve 2 of this problem, and that's it. Right. So I think we just kind of was on schedule, but a little bit behind. Not that bad. All right.